Hello friends, welcome to Joy of Life. So today we are going to look at a hard problem, which is problem number 52. The problem name is n queens 2. It's the extension of the main problem in queens, which I have done a video previously. You can check it out before checking this as well. I'll share the link as well in this video description below. Um, so let's look at the problem. The n-queen puzzle is the problem of placing n queens on an n into n chessboard such that no two queens attack each other. Given an integer n, return the number of distinct position to the n-queen puzzle. So we are supposed to return the count of possible safe configuration that we can have given a board of size n. So here you can see that these two are safe. Here none of the queens are under threat by other queens, right? So if you see here that all the queens are pretty much safe. So we need to see how many such placements are possible, how many such configurations are possible. So we are going to look at the problem in much more details and also come up with the code. But as I always do recommend that do give it a try yourself. You can refer to my other video which pretty much explains the solution as well. And then you can resume this video after you give it a try. So we have taken the example from the Leetcode where n equals to 4, and we have also taken a chessboard of size 4 by 4 wherein we have marked it with also numbers so that it's easier for you to understand. We have markings like A1, B1, A2, B2 and so on and so forth. So what happens over here? So when you are given with an empty chessboard and you have no queens and you are supposed to fill up the first row, which is this row over here. So what are the valid choices that you can make over here? So all these are valid choices because there are no queen, and if I have to place one queen, that queen will never be under threat, right? So what we are doing is we are trying to see our possibility space at every level and then go to the recursion. So at the first level of recursion, there is nothing on the board. And what are my valid choices at this level is we have all the choices are valid over here. So let's start with A1. So we at level 1 there are 4 choices that I can make from A1 through D1. So let's say we choose A1. So if I place a queen over here, what happens is these cells are not accessible to me for the next row, right? Because they are under threat of this queen. So if I place a queen here, this queen over here can kill this queen, right? So that is not a valid choice for me. Whereas the other two cells, which are C2 and D2, they looks pretty safe, and a queen can be placed there. So if I make a choice that is A1, my next two available choice would be C2 and D2. So C2 and D2 are the choices that I'm left with, right? So let's say mind it, we cannot place in the same row. So I am not talking about them. So that is negated by itself, right? So when I say put a queen at C2, what happens is for the next row, my these options are gone. So you can see here that from C2, there is no way it is possible for me to go into level 3. So if I choose A2 and then I make a choice C2, then I cannot proceed ahead. So this is taking me to a dead end. So I am not going to use C2. Let me see if I can make use of D2. So, so if I put a queen over here, what happens is my these options are gone. But I still have a choice to make at B3. And let me draw the lines. So this denotes the different level of recursion. So you can say this is my level 1, this is my level 2, and this is my level 3. Okay, so if I make a choice at B3, which is over here, what happens is my Oh God, I'm again left with no choices. So B3 is also pushing me to a dead end. So D2, B3, and I do not have any other child under A1. So we have explored the possibility space that if I place a queen at A1, do I have any other choices to make? And I see unfortunately there is no choices that I can make. So A1 could not make it. So what we'll do next is we'll check with B1. So now we put a queen over here. So once I put a queen over here, these choices went off for me. So the only choice that I am left with is D2. So D2 is my only option going with B1. So if I place a queen at D2, what happens is my these options are gone. I can still afford to put a queen at A3. So let me take that into consideration. So A3 is my viable option. So I put a queen over here. So once I put a queen, what happens is I check what are my eligible places over here. So as you can see that if I put at A3, now I can put one at C4. And let's say this is my level 4 of the recursion. So when I come to C4 and put a Q, and I see that my level is 4, which is my N as well. So at that moment, I know that this path, the entire path is a valid configuration for me where no queens will be under threat. So if I remove this crosses from the table, what you will see is no queen is attacking the other, or all of them are safe. So if you say this queen over here, diagonally it can go here, this side. Anyways, at the row and column, there is nothing. This queen is also not attacking anybody. This is also not attacking anybody. So all of them are safe and nobody is attacking anybody. So this is one valid configuration that we have found from B1. But keep in mind that we still have C1 and D1 unexplored, and we can find more such configurations from there maybe. So let me put a queen at C1. At putting at C1, what happens is my these options are gone, and the only choice that I have is A2 from C1. So let's say I have a choice A2, and I put a queen at A2, and for the next row, my valid choices are only this cell, which is a D3. So D3 is a valid choice for me. So let me put the lines. Okay, so I put a queen at D3, and what I see is my this option is gone, this option is gone, this will be attacked by it, and I still have a choice to make, and that is B4. I place a queen at B4, and what I see is that I have reached the level 4 of the recursion again. So that, having said that, that means that I can have a valid path which is not putting any queen under threat. So I have found my second option from here as well. As you can see over here, this is my second option. So here also, if you look closely, that no queen is attacking any of the other queens. All of them are placed safely, right? Now we still have one more choice to make at the initial level, that is D1. So if I put a queen at D1, what happens is my these two options are gone, and I am left with two choices, A2 and B2. So D1 can have two choices, A2 and B2. So let's say we are putting a queen at A2, and putting a queen at A2, what it means is my these options are gone. I still have C3, only option that's spawning out of A2, which is C3. And if I put a queen over queen at C3, what I see is that my this is not a valid option. So I see that again I hit a dead end over here. So C3, A2, so no other child of A2 is available. So this path is a dead path. So I still have B2 to look at. So what I'll do is let me remove from here. So I put a queen at b2, and placing a queen at b2 means that my these options are gone. This is also gone. Oh my God. I instantly came to a halt, right? B2 cannot be proceed any further. So my this option is also gone. So as you can see here, there are two valid paths that we can figure out from here. So these are the two paths, and all other paths are leading to a dead end. So what is the basic idea over here? So I have a possibility space at every state. So when I am at this level, I have a possibility space which is equal to the size n, right? I can place anywhere. And now I am trying that if I place it over here, what is my possibility space? So that is been depict all my possibility is coming out of a function, right? A recursive function basically. So what are we checking from this function? That initially everything is empty. Then we are putting a queen at a1. When I put a queen at a1, what is happening? I have two choices to make, c2 and d2. If I go at c2, I cannot proceed any further. So I fall back and go to d2. And from d2, I can see that I can go to b3. But from b3, I cannot proceed any further. So I fall back because I did not complete the board fully. Then I see that A1 has only two childs. Then I fall back to the main function again, and I start exploring B1. What if I put at B1? Then I have a choice at D2 and then at A3, and I could see that I could find a path over here. So this is how this entire problem breaks down into different choices. So at every level, if you look closely, that you have some possibility space, and we are exploiting this possibility space to see where we are meeting our exit criteria or the success criteria. So these are all my exit criterias. These are also exit criterias, but they are not successful exit criterias. These two are my successful exit criterias. And when we write the code, we'll also see that how this will be mapped into code, right? So let's move over to the code and look at the solution. So we are going to look at the solution, which is pretty much the same as the nquin problem, but here we need to return just the number of configuration that we have seen. So here the solution is pretty much the same as the nquin problem, but we need to return the just the count of the configuration, valid configuration where queens are not under the threat. So we'll be returning integer in this case, and we'll be calling our solve function. And just like the previous problem, we are going to create a Boolean array of the which is of the size of the board, and we are going to check for each of the rows. So we are going to check for the 0th row, starting from the 0th row. And if you remember that in the 0th row, all the combinations are valid. So we are going to choose each one, and then we are going to see on the next row what are our valid placement that is possible. So we'll look at the solve function here, which will return a int and which will take a boolean board, and it will also take the row that we are filling for. So initially it will be passed with a 0 from the total nquin function, and as we progress, we'll be incrementing the row and sending. And if we see at any point that our recursion has reached n, which is nothing but the size of the board, the length of the board rather, then we can say that we have found a valid configuration, and we are going to return a 1 in that case. Otherwise, what we are going to do, we are going to write a function. We are going to write a loop which will check for all the possible options for us over here. So we are going to check for each of the each of the cell in that row. So we are going to go through all the cells for that particular row, and we are going to ensure two things. Firstly, that cell should be a false. It should not be a true. So let's write down the condition over here. So board of row and I should be a false, and we are also going to check that is queen safe at that position or not. Is queen safe? So we'll write a method is queen safe, which will take a board. We'll pass the board to this function and we'll be passing row and I. So let's write this function. So this function should return a boolean is queen safe, and which will take a boolean array, which is the board, and it will take the row and the column, right? Recall that if we are checking for this cell, so we need to validate this and this, so horizontally and vertically. So if you are doing for this cell, so we will only check the top part because we have started filling from the top part, right? So when I'm filling this, I'll check this and this, so nothing up here. So for this cell, we'll check this and this. For this cell, we'll be checking this and this. So we'll also check the diagonal, but first let us do for the horizontal and vertical cells. So what we are going to do, we are going to write a loop for this. So we will be basically going through the board.length, and for any of the cell, if we see that we are getting so let's say row and I. So I am keeping my row fixed and I'm just incrementing my I. So I'm checking this. My row is fixed, right? If I'm getting a true anywhere over here, or I am checking my I and I'm checking my calls. So I'm keeping the column fixed and just incrementing this part, right? So I'm checking for all these cells, right? So if I see any of the fields to be true, what I can say is that this queen is not safe over here. So it is having a threat. Otherwise, what we are going to do, we are going to we are going to set I to row minus 1 and j to col minus 1. So what we are going to do is so for this cell, say we are putting a queen here. So I minus 1, j minus 1 indicates this cell over here. So I is decremented by 1, j is decremented by 1. So row is decremented by 1, column is decremented by 1. So what we are going to do, we are going to say while I greater than equals to 0 and j greater than equals to 0, we are going to continue this loop. And since we are going towards the left top diagonal from the position, so what will happen is I will be decremented along with the j will also be decremented. So if you see here, this is row minus 1, col minus 1. This is again from that cell row minus 1, col minus 1. Any point of time, if we see a board I or j is set to true, that means the queen is not safe there. So we can safely return a false, that queen is not safe. So just take this scenario. If I am placing over here and I start from here and going all the way diagonally to the left top corner, and if I see any of the fields to be true, I can that means that there is a queen here. So if there is a queen in this cell, so I cannot place my queen over here. So that's why I'm returning a false. Similarly, for the other diagonal, say I am placing here, so we have considered this diagonal, but we have not considered this diagonal yet. So we are going to do for this diagonal. So for this diagonal, what will be my initial condition? So I will decrement my row 1, and for j, which is my column indicator, I'll say column plus 1. So if you see here, if you take from this cell, if I go up, means I am decrementing my row. So row minus 1, and I am looking at the right diagonal, so this one. So if I say this column, so that means this is plus 1 from relative to this column, right? So I is initialized to row minus 1 and column is initialized to column plus 1, and we will continue to do it while so in this case it is a little different. What is happening is I is decrementing, so I have to check that I should be greater than equal to 0, and at every point the column is incrementing, so column j should be less than my board length. So as you can see here, what we are doing basically is we are decrementing I, but we are incrementing j, right? That's how we are going vertically towards the right top corner. Okay, and the condition remains the same. If at any point of time I see that my board ij is a true, is having a true, that means the queen is not safe here, so I will return a false. That means if I am placing a queen over here, I should see I should see that all of these should be false. If I see there is a queen over here, that means this placing this queen is unsafe. So if none of these conditions are met, that means my queen is safe, and in that case what I'll be doing is I'll be returning a true. That means my queen is safe there. Okay, so since my queen is safe here, so what I'll do is what I will first update my board. So I will put board of row and I to be true, to be true. And what I'll do is I will call the solve function again, right? So I'll be calling with the updated board, and what I'll be doing is I'll be filling up for the next row, right? So I'll be setting to row plus one. And if you remember when we did the dry run, so when we explored all the option A1 and moved to B2, we erased this. So that when we erased it, what does it mean? We are setting it back to false once we have explored all the options. So we are going to do something similar over here. So we will say that board of row and I, once we are done exploring, we can say that okay, I am done exploring it, set it back to false. And do remember, at every point this solve method is returning me an integer. So I also need to keep a track of the count, which is initially 0, and at every point whatever I get back from count, I am going to update. So in this case, count will return me a 0, count will return me a 0, count will return me a 1. I'll continue with this. I'll do a count equals to count plus 1. So we'll do this, which is count equals to count plus this will return me a 1. So the answer will become 2, and at the end count will hold how many combinations I have found. So this is the entire solution. This is the entire algorithm, which is pretty much the same as the row queen solution that we have looked at. So we'll run the code and see. So yeah, one few of the indentation were bad, and this was badly written as and it should be or. So I have modified it and did the indentation for you. Anyways, the solution will also be posted along with the description of the problem. So let's do a submit and check. So yeah, it has been passed. So let's submit it for a wider range of test cases and see. So yeah, it has been accepted, which is taking around 2 milliseconds of time. But again, the whole intention for solving this problem is to give you the idea on how we are coming up with the solution, how we are exploring our option space and limiting our options and coming up with the solution. So I hope you were able to get it. If you have any doubts or question, do feel to post a comment. I would try to answer it as soon as possible. So yeah, that's all from this video. I hope you liked the solution. Do let me know in the comments. Do share with your friends, and also please subscribe if you haven't done so, and that will keep me motivated on creating more videos. And thanks once again, and have a great day. See you guys. Bye bye.